Okay, so this is like a problem we were doing yesterday. I want us, though, to be thinking about what we would do if we did not have a graph. Okay, so let's first think about just what to do with a graph. 4, 5 is right here. There's A. And then -3, 1 is B. So that would be this side. So this side right here is 4, and the bottom is 7. Think you got it figured out? Okay, so Aiden was saying that we could take like 4 and this -3, and that would, but we'd take like the absolute value of this -3, so that would give us 7. That would work right there. But if we did it right here, 5 and 1 would give us 6. So his original plan that did work on the first problem would not work on this problem if we were trying to do it without the graph, right? So how could we come up with 4 and 7 every time without graphing it? Okay. Be more specific in what that one and the other one are. What do you mean? Okay, so you're saying like sometimes we're going to have to add the numbers and sometimes we're going to have to subtract the numbers, and we got to know why, right? Okay, I think you're on to something. I think that would work. Okay, what do you think, Riley? What do you mean, like? Okay, what do you think, Evan?
Subtract, like in this case, you would subtract 4 and -3, and you subtract 5 and all.
Okay, so what Evan's telling me to do here is to subtract my x's and then subtract my y's. Okay, so what happens here for the first one, if I subtract 4 minus -3, that becomes positive, and I get 7. And then I've got 5 minus 1, which will give me 4. Okay, that works. Right? What if I had done them in a different order, Evan? What if I had done -3 minus 4 and positive 1 minus 5? Okay, so this would give me a -7 and a -4 if I did it that way. Okay, so we know that like you can't have a negative distance, so we could do absolute value. Do we have to? So because after we do this, after we find these two numbers, what are we going to do with them? We're going to square them because we're going to put them into Pythagorean theorem, right? So we're going to do 7 squared plus 4 squared equals the distance squared, which is going to be 49 plus 16, which is going to be 65. And what did you get, Haley? 8.06. Give me one more decimal place there. 0.062. Okay? All right. Doesn't matter if I use a negative. Are you sure? Are you sure about that? Oh, Evan has just let the calculator lie to him. He's just let the calculator lie to him because
negative times a negative is positive.
Haley knows that negative times a negative is positive. Negative 7 times so you have to be careful with this because Evan has let the calculator lie to him. Long ago, I had an exchange student from South Korea, and he sat next to a poor little girl that did not know what she was doing at all. And she had to it was in pre-calculus. She had to have her calculator for every single thing, like 2 times 4. She wanted to use her calculator for. And Wu was his name. He would tell her, "Calculator is stupid." He would say, "In Korea, calculator is cheating." So if you rely on your calculator here, you will type in negative 7 squared. You will get negative 49, and you will be fooled because it does not equal negative 49. If you want to square something, in this case, you're plugging in negative 7 for your a, so that whole thing, the negative 7 is being squared, you have to put parentheses around it. Negative 7 squared is 49. So when we square negative 7, we get positive 49. When we square negative 4, we get positive 16. And so that is going to give us the same thing that we got over here. Square root both sides, 8.062 equals the distance. So does it even matter if we end up with a negative? It doesn't, because with Pythagorean theorem, it's going to go away because of the squares, right? The squares are going to make it positive whenever you do that problem. So, our strategy that we can use here, and this will work every time, is to find your horizontal section of your triangle. You can subtract your x's. And to find your vertical section, you can subtract your y's. And it doesn't even matter what order you do that in, because even if it is negative, the Pythagorean theorem will take care of it whenever you do the positives, or whenever you square. So let's try this one, which this one is too big to fit on a graph for us. So let's try this strategy with this example. So we would subtract our x's. Okay, so 45 minus negative 27. Or negative 27 minus 45. The only difference in what you'll get there is whether or not it's negative or positive. So for this, we will get, let's see, 72. And then we are going to subtract our y's. And we'll get negative 13 minus 12 will give us negative 25. So if we're thinking about our 2 points here, and this is our distance, I'm just drawing a general triangle here. The x's, that's our horizontal distance, that'd be 72 here. The y's, I'm getting negative 25, but really, honestly, you can just erase the negative if you want, because by the time you square it, it's not going to make a difference, right? So that vertical distance right there would be 25. If you want, you can include the negative when you do Pythagorean theorem. It'll be fine if you do that. But I would encourage you just to leave off the negatives, because it's only going to possibly make you mess something up in the calculator, right? You might, if you put your parentheses wrong, you'll get it wrong. So I would just do 72 squared plus 25 squared equals the distance squared. And definitely grab the calculator for that one. So 72 squared plus 25 squared is going to give us 5,809. And we will square root both sides. And we get 76.217. All right. So, what we're doing for 3 is we're going to try to come up with a general rule that will always work. Okay? So, first of all, we have done this sum with slope formula, right? We did slope formula where we did y2 minus y1 over x2 minus x1. So, you've seen this before. These subscripts here just mean like x from the first point, y from the first point. This is x from the second point, y from the second point is what we're doing here. So let's try the same thing that we just did with these points. Okay, so what's the first thing that we did? Subtract x's. So in this particular case, it doesn't matter which one comes first. I'm going to do x1 minus x2. Okay? Then what did we do? Subtract y's. So that was, I could do y1 minus y2. Or y2 minus y1. Doesn't matter which one comes first. Okay, so what I have came up with now, I got my triangle. The horizontal side is x1 minus x2. The vertical side is y1 minus y2. And I'm trying to find this distance over here. I've called it D, so I'm going to put D. All right, you're almost right. Okay. All right, I like that. I think that Isabella is right. We're just taking what we got here when we subtracted this, we're putting it into the Pythagorean theorem, right? Okay, I want this to be solved for D. So I want that D right there to be by itself, which means I got to get rid of that square. How do I do that? Square root both sides. So that means that D is going to equal the square root of x1 minus x2 squared plus y1 minus y2 squared. Okay, this is called the distance formula. And it just comes from Pythagorean theorem. It comes from the same thing that we have done. Whenever I first started teaching and I had to do distance formula, I just taught kids to memorize that formula and plug the numbers in. I never did this where we looked at the graph to go with it. But I think this is really helpful because a lot of students do not memorize that formula. If you go to my calculus class right now and ask them the distance formula, there's probably at least one of them that does not know what it is. I'll try to remember too if I can remember.
Do you know what classes they're on right now?
We're not going to go search them out. Most of them are not on campus because they're seniors, but there's a good chance they don't remember it. And that's why sometimes formulas are not the best. But if you know what goes behind a formula, like taking your points, drawing your right triangle, and finding the length of each side, then you might be able to hold on to that and remember that longer than just the formula. However, let's say you're maybe bad at that, at remembering what in the world to do. If you memorize this formula, you'll be able to find the distance every single time between your 2 points. So let me show you your two options of how you can do distance problems like we got here. There is always the option, if it will fit on a graph, to graph it and do it like we did yesterday. Okay, so that is always an option. If it'll fit on a graph, graph it, draw your triangle, do it like we did yesterday. Particularly on ones where they give you the graph, that might be the best way to do the problem. So, for this, here are your two options if you don't want to graph them. And today, I want you to not graph them, okay? So, it's a perfectly valid option, but I want you to practice this without graphing, because a lot of times you will get problems that you can't graph. Numbers that are too big to graph, and you're not going to be able to do you have to be able to do it without a graph. So you can either subtract your x's. In this case, that'd be -4 minus 6, which would give me -10. Subtract your y's, which would be 5 minus 7, which will give me -2. I'm going to draw the triangle just so you guys see what this is. Your x's would be here, you'd have 10. Your y's would be here, you would have 2. I'm going to ignore the negatives. It's just easier to do it that way. And so, then do Pythagorean theorem. 2 squared plus 10 squared equals the distance squared. So that's going to be 104 equals your distance squared. You will square root both sides and square root of 104. It's going to be 10.198. So if you do it this way, you don't have to have a formula memorized. You're just kind of thinking through how to make your triangle and do the problem. Or you can just use distance formula. So that distance formula looks like this. So you can, this is x1, y1, this is x2, y2. So some of you may prefer this because you can type it all into the calculator at once. So it'd be -4 minus 6 squared plus 5 minus 7 squared. And then you just type that baby into the calculator. -4 minus 6 squared plus 5 minus 7 squared. You got to make sure you get your parentheses right. And you get the same answer, 10.198. It is quicker. You must have the distance formula memorized for that. You have to know that formula, know what you're doing for that. But it is a little quicker. You can type it into the calculator for that. Okay, here. All right, so let's do one more together. It seems like one more, but this is another one of those evil problems. This is one of those evil problems that math teachers created to make you have to do 3 problems in one. So instead of asking you for the length of one side, they're asking for perimeter of a triangle. So you have 3 sides of this triangle, A, B, and C. Obviously, like yesterday, graphing is a good option, okay? So you can graph, but I don't want you graphing today because I want you to be able to do it both ways. So what I would do for this is I would just start by finding the length of AB. Okay? I'm gonna do this both ways because some of you may prefer one way over the other. You got your options. You could subtract x's, which is -4 minus -7, which is going to give you 3. you could subtract your y's, which is going to be 2 minus negative 3, which is 5. So you don't have to draw it, but your 3 would be here, your 5 would be here. So 3 squared plus 5 squared would equal the distance squared. That's going to be 9 plus 25, so 34 equals the distance squared, square root both sides. So distance equals the square root of 34. I'm going to leave it like that for right now. Okay. You do also have the option, instead, on this, we could have done square root of negative 4 minus negative 7 squared plus 2 minus negative 3 squared. And I would make those double negatives into pluses. And you could type that into the calculator. If you type it into the calculator, it's going to give you the decimal. You do also have the option. I'm going to show you why I'm not putting in the decimal here in a second. You could just do negative 4 plus 7 squared plus 2 plus 3 squared. That will give you 34. No, it's underneath the square root there. Or if you put it under the square root, you'll get the answer. So there's AB. We've got square root of 34. If you want to do the decimal, it's fine. Now we got to do the same thing for BC. Again, I'm going to do it both ways just so you see both ways. You don't have to do it both ways. Pick which one you like best. If I subtract my x's here, I'll have negative 7 minus 0, which will give me negative 7. Subtract my y's, I'll have negative 3 plus 2, give me negative 1. So that's going to be 1 squared plus 7 squared equals the distance squared. That's going to be 50 equals the distance squared. I will square root both sides. So my distance here equals the square root of 50. Is everybody with me there? I didn't draw the triangle on here, but you got your negative 7, negative 1. Those go into the Pythagorean theorem. I just erased the negatives because they're going to go away when you square them anyway. Okay? All right. If you wanted to, you could have done square root of negative 7 minus 0 squared plus negative 3 plus 2 squared. There. You can see how like it's the same parts, right? Right. Negative 7 minus 0 is negative 7 minus 0 right here. Negative 3 plus 2, negative 3 plus 2. Then you do Pythagorean theorem. All right, so we've got 2 of the sides. What would the last side be? We did AB and BC. What's the last one? CA or AC. So for AC, oh gracious, can't see it. We've got to subtract our x's, which is going to be 0 minus negative 4, which will just give us positive 4. Our y's, which is going to be negative 2 minus 2, which will give us a negative 4 here. Alright, so we're going to have 4 squared plus 4 squared equals the distance squared. So 16 plus 16 is 32. We will square root both sides, so we get square root of 32. So that's our last side. Or it would have been perfectly okay here instead to do square root of 0 minus negative 4, which is a plus 4 squared plus negative 2 minus 2 squared, like that. That'll give you the same answer and a little bit faster. So we have the length of our 3 sides, so we are going to do square root of 34. plus square root of 50 plus square root of 32. And if we do that, you can. If you have decimals instead, that's perfectly fine. If you type it into your calculator, just make sure that if you have an older calculator like mine that puts that parentheses, make sure you close the parentheses before you do the next square root. Or if you have the newer calculator that does the square root symbol, hit the over arrow so that you're not under the square root anymore before you do the second square root. Excuse me. I like typing it in this way because I don't have to worry about rounding decimals that might throw me off. But if you want to use the decimals instead, it works fine. So you get 18.559. Okay, questions? All right, it is really up to you whether you want to use the subtract the x's, subtract the y's, do Pythagorean theorem way, or whether you want to use distance formula, where you just plug everything into that formula. Either one is fine. Just know if you're using distance formula, you have to have that memorized. It's not going to be given to you. Okay? All right, so